So what I'm going to talk about today is mostly stuff that I did for my PhD. So as some people have covered already today, you know that the lab rat was taken from the wild about 150 years ago. 150 years ago in the wild, rats travel several kilometers a day patrolling their territory, going exploring. They live in burrows, and burrows really are the hub of their activities. That's where they raise their young, that's where they eat, that's where they seek shelter from the light, from temperature, from predators. Norway rats are also really good climbers, and they do that mostly to forage. And they also like to stand upright, and they do that while exploring and interacting with other rats. Similarly for mice, they too have been taken from the wild, and in the wild they engage in a wide variety of behaviors, including nesting, burrowing, climbing, foraging, standing. So, of course, in the laboratory, these animals are housed in very small cages where they don't have the opportunity to perform most of their natural behaviors. And if you really think about it, the cage is the most pervasive element of a rodent's life. And this is especially true for the nocturnal animals, so rodents, because when we're awake, they're sleeping. When they're awake, we're not there, nobody is around. And so really their life is limited to what they can do in that cage. And cages were designed in the early 1900s, and really they were designed for easy handling and cleaning, and the model, the shape, the size has changed very little since. And actually the dimensions are really more based on tradition, what has been designed years and years ago, than on any scientific evidence of what's good for them. So this is a video of what we've come to see as a standard laboratory rat. There's often pair housed or group housed, and they mostly sleep. So we come to think of rats maybe as these animals that are very sedentary, don't really do much, and that's okay. I just want to, as an aside, say that the orange hue in my videos is just a low pressure sodium lamp, so it's light that rats cannot see. It appears dark to them, but we can see fairly well. So the question that I have, or I had for my PhD, was, is this really what rats are? Are they content this way? So specifically, I wanted to answer whether rats, how motivated they were to burrow, to climb, and to stand upright, despite having been bred in these small cages for over 150 years. So for my experiments, I used, these are actually pet rat cages, which allow climbing because they're made of horizontal wire bars. I provided them with soil at the bottom so they could burrow. I obtained them just at weanings from a commercial rat breeder and filmed them for over 1 year. And I recorded the frequency of burrowing, climbing, and standing upright when they were 3, 8, and 13 months old. And we had 5 female spec dollies in every cage. And as a control, we also got some rats that were randomly selected to be housed in standard cages. They were pair housed, and of course they could not burrow, stand, or climb. And the reason I want to look at standing upright specifically is regulations within the EU, North America, say that cages can be 18 to 20 centimeters tall, but rats actually stand at 26 to 30 centimeters tall when they're grown. So just as a contrast, I'm going to show you a video of what these rats did when they were placed in these environments. So bear in mind, these are laboratory-bred rats. This video is a little sped up to show more stuff, but clearly they don't just sleep and lie around. They are actually quite active. They do stand around and climb. So I'm going to go one by one through the 3 behaviors that I looked at. So burrowing did happen. As you can see, here's some pictures of what it looked like. And here's a video. So rats, as I think Tim said earlier, really do love burrowing. They do it a lot, even though they haven't had the opportunity to do it for years. And it's actually one of the first things they do when you put them in this cage. So in terms of some graphs, some results, on the y-axis you have the frequency per rat of how many times they burrowed in a 24-hour period, and on the x-axis you have the age at 3, 8, and 13 months. And as you can see, rats burrowed approximately 30 times per day, and that remained stable throughout the year that I looked at. So mammals and rats become less active as they age. We know that. However, burrowing remains stable. So given that they traded some activities to rest instead of performing them, but they did not trade burrowing, can suggest that it's actually really important behaviors that they're not willing to reduce or to trade. They also burrowed a lot even though the burrows were already present. So they would constantly, every day, the entrances to the burrows were different. It's not because they were collapsing. You can see from the videos, they just constantly wanted to dig, and they were starting new burrows and burying others. Their gait while they were burrowing also suggested that it was something that was reinforcing or something that they enjoyed. Often they'd be hanging out on the top shelf, and they would just suddenly, like a flashball went up, they would jump up and run down and start digging. And as they were coming in and out of the burrows while they were digging, they were very jumpy and excited. So climbing, kind of self-evident. This is what it looked like. So similar graph, you have the frequency of climbing on this axis and the age on this one. Young rats climbed about 80 times per day, but it actually reduced quite a bit when they were aging, as they got older. So it's not as frequent as the digging, at least when they're older, but it still adds to their behavioral repertoire that is very limited in a cage. We think that it declined because of physical ability, and it was quite clear once the rats were about 8 and certainly 13 months old, they just weren't as dexterous, and they would sometimes slip and fall. And studies have shown that muscle coordination and strength does reduce with age. Rats are rarely housed until they're 8 months old, so for these young rats that we usually keep, it looks like climbing is still an important behavior. Now, upright standing, we noticed that there were 2 types. This was the most common one, and it seemed to be exploratory, so the rat was standing and sniffing, and the head was moving. And this one, you can't really quite see on the picture, but it's more of a stretch, and so the rat has the back arched and is often yawning. And I'll show those 2 in the video. So this rat here is doing the exploratory type. You can clearly see the head moving, kind of checking out what's happening in the higher level of the cage. And now pay attention to this rat. She is about to stretch. Here you go, and then this one is going to do it too. Right. So, again, frequency on this axis, age here, super frequent. So the young rats stretched about 180 times per day. Even at 13 months old, they still stretched about 75 times per day, which is as frequent as climbing. Very frequent. It's been suggested that stretching of the limbs and of the back is really one of the primary systems of behavior, and that is the basis of behavioral needs. So it seems to be something important that we're not letting our rats do. In farm animals, where the issues are more open to the public, people are strongly opposed to restrictive housing that doesn't allow the animals to stretch or stand up. This public opposition has actually led to the banning of battery cages for chickens and small enclosures for sows and hens, also in the US. So it's possible that if the public was aware how rats were housed, that they would also push for something better. So, because these standard rats, they cannot stretch upright, because as I showed, they also do it to stretch. I wanted to look at whether they would compensate by stretching laterally, so kind of like in the pictures. Would they do it more to compensate for the inability to do it upright? Indeed, they do. So Semi-naturalistic rats, or the big cages, they stretched laterally about 6 times per day. Standard rats stretched about 9 times more. Then what I looked at was stretching, both upright and lateral stretching in the semi-naturalistic cages was still about 1/3 of what happens in the standard cages. So clearly they're not only compensating for the inability to stretch upright, something else is going on. And if you look at the literature around stretching, it is actually a corrective response to stiffness caused by positional stress or immobility. So we've found some evidence that the fact that these rats can't stand upright, can't really move much, possibly leads to stiffness, and this is why they're stretching all the time. So in summary from this group of studies, we found that standard laboratory housing prevents important natural behaviors, and they're quite motivated to perform frequently throughout the day, and that standard housing likely leads to stiffness and positional stress. The question is, though, does not allowing them to perform these behaviors impact their welfare, impact how they're feeling? So what I used was anticipatory behavior as a tool. Briefly explain what that is. It's basically, you provide the animal with a cue, you wait, and then you give them a reward. So think of you're going to walk your dog. Let's say you put your shoes on. Your dog associates you putting your shoes on to going for a walk and starts getting excited and running around you. That's the anticipatory behavior. They're anticipating something good that's going to come, and they get excited and they move a lot during that period. So what I did is I trained my rats to associate a beep sound, waited 5 minutes, and then they got a slice of banana. And the literature on anticipatory behavior shows that impoverished conditions or stress leads to being more sensitive to rewards, and then therefore leads to stronger anticipatory response. So if you are a stressed person or you're impoverished, if you are about to get something good, you're going to be more excited, anticipating it more than someone whose life is good and gets lots of treats. Basically, stress or impoverished conditions lead to stronger anticipatory behavior. And it's also been shown that this reward sensitivity and the stronger anticipation is related to the animal's subjective evaluations of their own state, so how they're feeling. So I tested the same rats that I just showed in the videos previously, but I tested them when they were 19 and 21 months old. And then the way anticipatory behavior is measured is just how many different behaviors they perform, how many shifts in those 5 minutes. So these are the results. This is the frequency of behaviors per minute. This is just the 2 experiments where they're 19 and 21 months old. My enriched or semi-naturalistic housed rats are in orange, standard are in gray, and clearly the standard housed rats will have much stronger anticipatory behavior, suggesting that they were experiencing poor welfare. Same, just to reiterate. So evidence that standard housed rats are experiencing poor welfare, and as judged by having a stronger anticipatory behavior. So the potential reasons for them having poor welfare could be that they cannot perform some natural behaviors, but other differences between the 2 groups were also that my enriched rats had a larger social group. They were 5 rats, which is more of the size they would have in the wild. And they also had regular access to treats. And I'm going to talk about that just a little bit to give you maybe some ideas of things you can do. Because larger cages are obviously not always possible. It's costly, it's more labor. So I just wanted to give some practical ways of maybe making the animals' lives a little more interesting by engaging some natural behaviors. So some stuff that I did with my rats is collect a bunch of toilet paper rolls, and you can wrap up some treats, some hay, some paper in there, toss that in their cage, and then they spend some time having to figure out how to open it and then finding the treats. What I've seen done at my facility as well is just wrapping some rat chow in paper towel that is also available at the facility, and again, just engages that have to work a little bit more on accessing those treats, and it gives them something to do. What they really liked as well is you can put some hay or just strips of paper towel on their lid, and then they have to work through pulling them and then line their nests or their burrows with it. And you can also use treat balls. This is a commercially available one for cats from the pet store. And my rats quite enjoyed it. So this one fell into a burrow, so it's actually at the bottom in the ground. Another thing they really liked is just think of small treats that are healthy. Something like oats or puffed rice cereal, sunflower seeds, or shredded coconut. You can add that to a little bowl and then mix that in with bedding that you have at your facility. And they really will spend a lot of time going through this and picking out all the little pieces. So it engages some digging, as well as just gives them an activity to do for quite some time in the day. And you don't have to use a bowl. You can use it if you just change the cage and the bedding is clean. You can just put that in there as well. And then the surface area is a lot bigger. And this is just a picture of what it looked like. I gave them big bowls in my big cages. And I mean, they'd sit there for 15, 20 minutes rummaging through. They'd go back throughout the day to see if they haven't missed anything. I also added some strips of paper. You can put really anything in there. And then the strips of paper, and if you do hay as well, they can use that to line their nests or wherever they sleep. All right, laboratory mice. This is a newer study. We're still analyzing it, but I have some prelim results. Just like rats, they're housed in shoebox cages. Same, they don't really get any opportunities to forage or to explore. This model I know it's not really used in the EU, but it is something that's quite popular in Canada. They're just these triangular shaped, and then they go on this cage rack that's circular. But the reason we got interested in this particular cage is that this provider, these cage people, also make this tube that allows you to connect a few cages together. So we were just interested in seeing what would mice do if you connected a few cages. How would they use this space? Particularly, where would they sleep and where would they soil? So this is what these cages look like on the cage rack. We decided to connect 3 cages together. So here's one. This is our control cage that's not connected to anything. As a graphical representation of what these triads look like. In every triad, we had 1 cage that was red. Only 1 cage was provided with food and water. All 3 cages were given nesting material, and all 3 cages were filled with bedding. Every cage had 3 mice, but really what this meant is that there were 9 mice in the whole system, and we used female Swiss Webster mice. So data collection was done by Tina, who was a wonderful animal care technician who was involved with this study and adores mice. She was quite keen to participate and try to see what these mice would do. So what she would do is at cage changing once per week, she developed this score sheet that she would fill in. Here's just a little zoom into what is on the score sheet. That's just, again, a representation of the 3 cages. This represents where the food was and where the water was. So at each cage changing, she would then note where the nest was and what the nest score was to look at nest quality. And she would write down where the urine spots were. Just for nest scoring, we used this nest scoring, that it's a published way. 0 means flat, 3 is a full dome, so just gauging the quality of those nests. What Tina also did is at cage changing, after she's filled where the nest and urine was, she took a picture from the top and the bottom of every cage. And so that was documented. Later on, we scrambled all the pictures and blindly scored for every cage what the soiling level was in the cage and how much bedding was in the cage. So what did the mice do? Here's back to the representation. So even though we gave nesting material in all of the cages, we found that the mice always dragged it and made 1 giant nest. And in 86% of the time, this giant nest was in the red cage. 65% it was in the red cage, and 86% of the time they only built 1 nest. What we also found, this is not scientific, yeah, because we don't have enough replications, but the higher on the rack, so the brighter it was, the more likely they were to have one nest in the red cage, and the lower you moved, the more likely they were to have two nests, so not necessarily in the red cage. What we also found is with the one nest, if it wasn't in the red cage, then it was in the non-food cage, so it would have been in this one instead of this one. So never nesting in the food cage. What we found also is that the nest cage, whichever it was never the one that was the most soiled, and it was actually usually the one that was the least soiled. And the food cage was the one that they soiled the most, almost 90% of the time. What we also found is that the most soiled cage always had full bedding. It had the highest bedding and the most of it. The other cages usually had at least 1/3 of their bedding removed, and many of them had 2/3 of their bedding removed. So if we go back to here, this is what it looked like. Barely any bedding left. So what this tells us, just as pure observational studies, that mice really prefer to sleep not where they defecate. So they prefer to have a clean sleeping area and soil one specific cage. They also prefer to sleep in the dark, which was most often the red cage, if it was high in the rack. And they do drag bedding between the cages, which is something we hadn't anticipated. Our best guess is that they're trying to cover up their waste or maybe dilute the smell in some way. So that definitely warrants more study to look at what's going on there. So in conclusions, we've shown both for bats and mice that standard housing does prevent the performance of many natural behaviors. For rats, climbing, burrowing, standing upright. For mice, these things as well, on top of where their choice of where they want to sleep and how close they want to be to their own soiling. We've shown that housing them in these different or more natural ways can improve their welfare. We also argue that it can increase job satisfaction, or at least that was true for the facility where I was at, because seeing rats be rats and do stuff was so exciting for the lab techs that are working with my animals. They confessed to spending more time with those animals, to coming in just to watch them, and I think they really enjoyed that. It can potentially decrease labor, which is also a really good outcome. So for the mice cages, what we found is the techs were actually able to change only the latrine, so the dirtiest cage, every other week. So every other week, they didn't have to change all the cages, but only one. So that concludes my talk. I really wanted to thank the NC3Rs for inviting me to be here, and I need to mention these two individuals, Dr. Danwery, who was my PhD supervisor and was involved in all the studies I talked about here, and Dr. Becca Franks was a postdoc at our facility and helped as a co-author on the mouse study as well. She did all the stats. Thank you.
Thank you.